All right, and here we are with add and subtract polynomials with me, Mr. Hain. And our central question for this section of the video is, how do exponents help me add and subtract polynomials? So let's dive right in. So this looks scary because we got so many terms. We have 4 terms, and then we have a grouping symbol, and then we have an addition sign, and another 4 terms inside of another grouping symbol. But it's not that bad. We're going to use those exponents to line up our terms. So the x cubed are together, the x squareds are together, the x's are together, and the constant terms without an x are also together. And now all we have to do is deal with adding the coefficients of each variable with an exponent. And so, as promised by some people in my class, I'm going to regale you with my horrible singing, and I apologize, but this is the adding and subtracting integers song set to the tune of Row, Row, Row Your Boat. Same signs, add them up, different signs subtract. Keep the sign of the larger number, then you'll be exact. And that's what we're going to do. The 9 and 13 are different signs, so I subtract. 13 minus 9 is 4, so it'll be 4x cubed. These are the same signs, so I add them up. 7 plus 2 is 9x squared. These are the same signs, so I add them up. That is 13x, and the larger number is negative, so it's negative 13x. And then I have 3 and negative 6, and those are different signs, so different signs I'll subtract. 6 minus 3 is 3, and the larger number is negative. So my answer, 4x cubed plus 9x squared minus 13x minus 3. So use that song, the add and subtract integer song, and our example for example 1, and go ahead and do checkpoint 1. I'll be here when you get back. And we're back with example 2. So now let's subtract polynomials. So from what we know, we automatically just line everything up. So that's cool. But notice that I'm subtracting the entire quantity in my original question. That means I'm actually going to be distributing that negative sign. So the negative sign on the outside of the second set of numbers actually changes the sign of each of the terms. And we see that just like this. So you see I have negative 4 because it was positive. This negative 6 turned positive. This negative 7 turned positive. Remember that integer song? Same signs, add them up, different signs subtract. Keep the sign of the larger number, then you'll be exact. And it guides us through our process here. We have simple subtraction, 3x squared, a simple addition, 9x squared, integer addition, which the song leads us through. These are different signs, so we subtract. 7 minus 4 is 3, and the 7 is larger than 4, farther away from 0, so it's positive. Go ahead and use the song and our example to do checkpoint 2. I'll be here when you get back. Go ahead and pause that video. And we're back. So let's make this as hard as I possibly can. What I'm going to do is I'm going to say subtract the first group from the second group. People get confused, they line them up wrong, but really subtract from means I'm going to take the second one away from the first one. So just like we did in the last example, I'm going to distribute the negative. So the positive turns negative, the negative turns positive, the negative turns positive, and then positive turns negative. Use the song to guide you through the ones that are integer operations. And 7 minus 2 is 5x cubed. These are different signs, so I subtract. 8 minus 6, 8 is farther from 0, so it's negative. Negative 2x squared. I add these up, 12x. I add these because they're the same sign, and 9 is farther away from 0, so I have negative 15. So go ahead and use example 3 in the integer song to guide you through checkpoint 3 and checkpoint 4. Pause the video. I'll be here when you get back. And we're back with the next section, which is multiply polynomials. And with me again, Mr. Hain. And our essential question is, how do exponent operations help me multiply polynomials? So let's take a look and deep into polynomials. Let's dive right in. So we're going to use the product rule. So when in doubt, I'm going to actually expand out this first term. So I have 2 2's and 3 2's. So 2 2's times 3 2's means I have 2 of them and then 3 more of them. So I'm going to add the exponents. So when I multiply exponents with the same base, which is in this case 2, I add those exponents together. Kaboom. 2 to the 5th. Same thing with b. Those are the same base. I see it has x. So I'm going to go ahead and add those exponents together. And I have x to the 7 plus 9, which of course is x to the 16th. The only difference that I have with c is that I see that the first term, y, has no exponent. But how many y's are there? There is one y. And so when there is no exponent, the exponent is 1. So y to the 1 plus 5, which of course is 6. And d, I'm getting as complicated as I can when I'm using the product rule. There's 3 terms, so I'm going to add all 3 of them up. And that, of course, is 10. So go ahead and use these examples to guide you through checkpoint 1. Pause the video, and I'll be here when you get back. And we're back with the power rule. So the power rule is a little bit different. It says 2 to the 3rd, and that is my base, that I'm going to multiply times itself 5 times. And it looks like this. I have 5 2 to the 3rds. In other words, I have 5 3s. So I could do 3 plus 3 plus 3 plus 3 plus 3. However, we know that repeated addition is multiplication. So that means I can go 3 times 5. And of course, that's 2 to the 15th. So now we have x to the 6th to the 4th power. So I'm going to multiply 6 times 4. It's x to the 24th. And here, don't let the multiple grouping symbols throw you. It's still negative 3 raised to the 7th raised to the 5th. So that's negative 3 to the 7 times 5, which of course is negative 3 to the 35th. So go ahead and use example 2, A, B, and C to check out checkpoint 2, A, B, and C. Pause the video, work them out. I'll be here when you get back. And we're back with example 3, products to powers. So we're going to actually take a product of numbers here, which is 5x, because I'm multiplying them together, and raise it to the 3rd power. What that means is when there is no exponent, the exponent is 1. And whenever I see a number outside of a parentheses, I love to distribute. So that's why you see me have 5 to the 1 times 3, and then x to the 1 times 3. And of course, this is very difficult multiplication. So 5 to the 3rd, x to the 3rd, and I know if I have 5 times 5 times 5, using a calculator, I do know that is 125. X to the 3rd power. Awesome. So now I've got the same thing with the second example, that 2 did not have an exponent, which is why I skipped ahead and gave it the exponent of 1. I'm going to multiply the exponent on the outside, which is 5. I'm going to multiply 1 times 5 and 4 times 5. Cool. That gives me negative 2 to the 5th and y to the 20th. And since I simplified my previous example to just a standard form number, I'm going to take negative 2 and multiply it times itself 5 times. That's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And of course, that gives me negative 32. Y to the 20th. So in that case, that's all I've got left. So go ahead and pause the video, work out checkpoint 3, A and B, using my example 3 as an example to go ahead and help you out. Pause the video and I'll be here when you get back. All right, let's multiply some monomials. So then I'm just multiplying these terms together, and it looks complicated, but it's not. So what I'm going to do is I'm actually going to multiply the numbers together, 2 times 4. And then I'm going to multiply the exponents together, which is x times x squared. I'm going to break this up and then do each part on its own. 2 times 4 is 8. Same base. Add the exponents when I multiply, so that should be x to the 3rd, 8x to the 3rd. Boom. The same thing happens with b. I'm going to multiply the negative 10 times the 6, and the x to the 6th times x to the 10th. See, I have different colors to help you see it. Negative 10 times 6 is negative 60. Same base, I have x, so I'm going to add 6 plus 10, so that's 16. Negative 60, x to the 16th. Awesome. Go ahead and pause the video. Do checkpoint 4 and A and B. I'll be here when you get back. So we are slowly but surely ramping up the difficulty of what we are doing. And so I'm going to take a monomial outside of a parentheses or grouping symbol, and I'm going to multiply it times each term inside of a binomial. So Let's take a look at what that looks like. I've got 2 times x times 4. So 2x times x times 4. So what that means is I'm going to multiply the 2x times the x, and of course that is 2x squared, because x times x is x squared. And then I have 2 times 4, which is 8. And this term on the outside has an x, so it's 2x. There is no x for the 4, so it's just 2, the numbers multiply and the variable stays. That's why I have 8x. Awesome. So let's use that same principle so that we can multiply all of the terms for b. And sorry, I skipped ahead a little bit, but I multiply the numbers, which is 12, add the exponents, which is 5, so 12x to the 5th, multiply the numbers, 3 times negative 5 is negative 15, x squared times x is x to the 3rd, and 3x squared times 2 is 6x squared. Okay, so the key term here is to multiply and break down. It's exactly what we did in the previous slide. You multiply the numbers, then you multiply the exponents in the exact same way. So go ahead and pause the video, do checkpoint 5 A and B, use the example 5 as a guide to what you are doing, and I will be here when you get back. All right, last couple of slides for these multiplication of terms. And so I have here x plus 3 times x plus 2. And now I'm going to use what's called the seashell. It's my own thing. Some teachers teach FOIL, first, outer, inner, last. Doesn't make a difference. What I do is I just take the first number and multiply, first term in the first group and multiply it times the first and then the last. And then the second number in the first group, and I'm going to multiply times the first and the last. All right. What that gives me is x squared times 2x. This x times x is x squared. The x times 2 is 2x. Then the red arrows guide me. 3 times x is 3x, and 3 times 2 is 6. And here in the middle, I see I have two terms that are the same. 2x plus 3x is 5x. So I'm going to combine like terms, and I'm done. So the same thing happens with my second example. I'm going to use some arrows and color code them to help me out here. So I'm going to multiply the 3x times the 2x, and I'm going to get 6x squared. The 3x times the negative 4 is going to give me negative 12x squared. That's the green arrow. The purple arrow here on the bottom gives me 7 times 2x, which is 14x, and then the 7 times the negative 4 is giving me negative 28 in the plum. So I have two terms again in the middle that I can combine. I use the integer song to guide me. These are different signs, so I subtract. The larger number here is positive, so plus 2x is my middle term. 6x squared plus 2x minus 28. So go ahead and pause the video, do checkpoint 6. Use example 6 to guide what you are doing for checkpoint 6. I'll be here when you get back. Awesome. Let's get to our last example. All right, so I'm going to multiply these together. It looks crazy, but I'm just going to draw arrows. That 2x multiplies x squared, 4x, and 5. That 3 multiplies x squared, 4x, and 5. I'm color-coded all of them, so I have 2x times x squared is x2x cubed. 2x times 4x is 8x squared. 2x times 5 is 10x. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times 5 is 15. Now I've got multiple terms that I can combine. So as I'm combining these terms together, I'm going to group them with a similar color. So I've got the 8x squared and the 3x squared. And when those two terms combine, I get 11x squared. Then I have the 10x and the 12x. Those add together, and I get 22x. That allows me to have 2x cubed plus 11x squared plus 22x plus 15. Go ahead and pause the video and use example 7 as a guide for checkpoint 7, and I'll be here when you get back. And that's it, ladies and gentlemen. Till next time, keep doing the math.